Hi, 8th grade. Mrs. Hedrick here. This is Math 8. Today is April 29th, and we are going to be working in Lesson 29. So we're starting this understanding angle relationships. So we're going to talk about, actually, this lesson today, there's very little actual activity, and it's almost all vocabulary. So we're going to go over these together. Make sure you understand the words. You might very well want to get your notebook out and write these down. Lesson 21 in your notes. I have my pencil. I have a ruler. I'm going to do some drawing. If you're going to draw on another sheet of paper, you might want that. And look at all my fun colors. I got lots of colors and a highlighter. Okay? So you might want to pause me and go gather those things. Okay. So I'm going to be talking a lot today. You're going to need to pause this. You might want to rewind it and listen to it again. There's a lot of vocabulary that we're going to go over, okay? And most of this is not new. I'm teaching 7th grade geometry right now, and we've been talking about this, okay? So we'll see if it can refresh your memory. Okay, where can you find pairs of angles that are congruent? So congruent means same size, same shape, okay? So they started with, they've got a couple of pictures here. I think that most of us are familiar with this, right? If I have two parallelograms, I know that these are corresponding angles, right? When I lay these on top of each other, they match. So these two angles are going to be congruent, right? This angle is going to match that angle, right? That's important to know. The example they have here, they have these two strips of like paper, and these lines are parallel. These sets of lines are parallel, and then they come across with this dashed line and they cut it. So let's go back and read what they're saying here. You know that vertical angles form by two intersecting lines that have the same measure so that they are congruent. You can also find congruent angles whenever parallel lines are crossed by another line. Okay, so that's what's happened here. If you draw two parallel lines, we actually end up, if you look, 1, 2, 3, 4, there's two sets of parallel lines there. These are really close together, but they're all parallel to each other. When you come through and draw a line, this line is called a transversal. Okay, that's that definition coming down here. And it says if you place parallel strips of paper side by side and using a ruler you draw a line across them and then you cut the strips on the line. So if I got scissors out and cut those, where would you expect two angles to overlap perfectly? Like this. Where would they overlap? Well, that kind of looks like that, doesn't it? If I cut the edges, they would look like that. Slide one strip on top of the other as shown above to check your thinking. Okay, so if you get in here, I know it's teeny tiny, but if you look, angle 1 here should be the same as angle 2 up here. Okay, and if you really want to blow your mind, angle 3 up here, all three of those should have the same measure. Those should be congruent, same shape. Well, actually, it's just same size, right? Same amount of, the angle is the same size. I'll get it out. Okay, let's keep reading. Now we've got some vocab. So get a highlighter. When a third line cuts or crosses two lines, it's called a transversal. So those lines should be parallel. So when a third line cuts across two lines, it's called a transversal. So this is a transversal. Now, if you're writing your own notes, draw this in your notebook. Draw two parallel lines. Actually, here. Where's my? Oh, here. I have plain paper. So I'm going to do this. If I make my, look, I'm going to cheat. Here's my, look, can you see it? Scooch it down a little bit. I'm just going to draw one on each side. Right, that makes them parallel. This line that comes across, this is called the transversal. It's the line that cuts across the parallel lines. Okay? Let's go back to our thing. I'm going to keep going back and forth. Okay. When lines are parallel, the transversal forms pairs of congruent angles called corresponding angles. Uh-oh, new vocab word. Let's highlight it. Corresponding angles are angles that are in the same position in the intersections of the transversal and each of the parallel lines. Okay, so let's go to our little picture. Corresponding angles are angles that are in the same position at the intersection. Okay, so if I cover that up, let's pretend we're driving down the road. Maybe this is a crazy intersection. My daughter lived near Cleveland, and they have the goofiest intersections ever. You know, most intersections look like that, right? Like a T. But let's say it's a crazy intersection like this. Okay, and here's the other intersection. If you're in the same position at the intersections, you're corresponding. So let's say I'm here at this part of the intersection. Where's the match up here? Well, this is kind of what, like bottom left? So bottom left, those would be corresponding. Oh, here, I forgot to get my colors out. I'll make them red. So those two red angles are corresponding. Same position at the intersection. So these are corresponding angles. These two. Now, there are other ones, right? So if I came in here and I did, what if I did this one? Bottom right. Well, here's the bottom right. So the two blue ones would also be corresponding. Okay? Same position at the intersection. Those are corresponding angles. I told you, a lot of vocab. Let's see, the transverse, okay, angles 1, 2, and 3 above on the parallel line to the right of the transversal, so they're all congruent. I just mentioned that, right? 1, 2, and 3. They're all on the upper right of the intersection. All congruent, same angle. All right, we got a little bit more. Okay, you can reason the alternate interior angles are coordinate. Okay, another vocab. Alternate interior angles. Okay. You can combine what you know about congruent vertical angles with congruent corresponding angles to find pairs of congruent angles. Okay, they threw another one at you, and I don't think, no, okay. It isn't highlighted, but we're going to highlight it. Okay, we have to talk about vertical angles. I'm doing 7th grade math right now, and we're doing vertical angles. So we did this last year. So let's go draw a picture, okay? I'm just going to draw two lines that crisscross. I'm going to draw them over here. Okay, so let's say these two lines crisscross. Okay. Vertical angles are angles that are opposite of each other. So vertical and opposite angles are the same thing. So let's get a, how about purple? Vertical are the same as opposite angles. And sometimes I call them vertical and sometimes I call them opposite. Okay, here's how I remember. Vertical has a V. Can you see the V? Do you see a V over here? I do. Here it is. There's my V. The angle here, the angle opposite of that. So jump across. These two angles are vertical angles or opposite angles, and they are congruent. So this is an example, and these are congruent. Same measure. Okay, now, if these two are congruent, what do you know about the other two? They are also opposite, right? These two are acute, these two are obtuse. Obtuse, obtuse. Those are also vertical. They're vertical to each other, right? This isn't vertical to that. Those are another definition that we're about to look at. So just to remind you, vertical or opposite angles, those are the ones that, when two lines crisscross, they're the ones across from each other in the V shape. Okay. Okay. All right, let's read. Because angle 2 and angle 5 are vertical angles, so can you see it here in the picture? Let me slide it up. Hang on. Okay. Angle 2 and angle 5 are vertical. Do you agree? There's the X. They're opposite of each other. Yes. So now look, this is how we write it mathematically. This says angle 2 is congruent to angle 5. That's what that means. It looks an equal sign with a wave on the top. This means congruent to. So you could replace it with those words. Angle 2 is congruent to angle 5. So these two have the same measure. They go on. Angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. Hey, we just talked about that right here. Corresponding angles, right? They're in the same location at the intersection, top right, top right. Angle 1 and angle 2 are congruent because they are corresponding angles. So that also means that angle 1 and angle 5 are also congruent. Now this one's a little trickier. 1 and 2 are congruent, right? Same spot at the intersection. So these two have the same measure. They're saying because these are vertical, they're the same. So that makes these two the same. Ah, that's crazy. 1 and 2, same measure. 2 and 5 are vertical. I got a little bug in here. Go away, little bug. I got a gnat. Did I get him? I'm sorry about that, guys. 2 and 5 are the same because they're vertical. 1 and 2 are the same because they're corresponding. So that means 1 and 5 are the same. Whew, that's a lot. Okay. Now, 1 and 5 have another special name. Okay, and here it is. Angle pairs such as 1 and 5 are called here alternate interior angles because they are inside between the two parallel lines and they are on alternating or opposite sides of the transversal. Oh, I got him. Oh my gosh, I'm sorry I had to witness that, but he was driving me crazy. I have a gnat in here. Okay. Okay. All right. Alternate interior angles are congruent if they're created by parallel lines. Okay. I'm going to draw a picture of this. All right. So I'm going to go back to my paper. So these were corresponding. Same location at the intersection. The transversal is the line. Vertical angles are opposite, right? Okay. Let's talk about alternate interior. So again, I'm going to draw a set of parallel lines. My cheater method. I'm going to draw a transversal to cut across. Okay. Now, our books are numbered all crazy. I'm going to go and put some numbers in. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the angles that they're talking about, how about, can you read my green? They're talking about alternate interior. Okay, alternate. So when things alternate, they go back and forth. Alternate, 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 left and right, up and down, back and forth. So that's what we're going to do. We're going to alternate. So alternate might be on the sides of the transversal, right? So 1, and then I could go over to 4, and then I could go to 5, then I go back to 8. So those are alternating. Interior means inside. So I'm looking at angles that are on the opposite sides of each other, but they're inside, interior, inside of these two lines. Does that make sense? So alternate interior. So what are the interior angles? Well, 3 is on the inside, 4 is on the inside, 5 is on the inside, and 6 is on the inside. Which ones are opposite of each other? Now I'm going to pick 3. It's interior, and now I want to find that's the one that's opposite. So I'm going to alternate. So now I'm on this side of the line. Now I want to flip to this side. But now I want it to be on the inside. So 3 and 6 are alternate interior angles. Does that make sense? There's one more set of alternate interior angles. Do you see them? I hope so. 4 and 5 are also alternate interior angles. So they're opposite. So OPPSIT, opposite of the transversal, and then they're inside parallel lines. That's what makes them alternate is this part, interior is that part. Okay. Whew, that's a lot. Okay. And they're congruent. Alternate interior angles are congruent. Okay, so I should probably add that. Oh, look, we should go back and add that to vertical. Oh, I did that. Vertical angles are congruent. Corresponding angles are congruent. Okay, so I added that to that. So these are congruent to each other, and these are congruent to each other. Okay, let's turn our page. No math yet. Woo. Okay, well, it's all math, but no work. Okay. All right, let's crank out another one. Adjacent supplementary angles, such as angle 2 and angle 6, are called linear pairs because they form a line. Another linear pair is angle 5 and 6. The sum of the measures of angles in a linear pair is always 180. Okay, so there were a couple of things. So supplementary angles. Again, I'm teaching 7th grade right now as well, and we've been doing complementary and supplementary. Okay, so let's write some quick notes. They didn't mention them, but I'm going to mention it to you. complementary, I hope I spelled that right, angles are two angles that equal 90 degrees. Do you remember that from last year? And supplementary angles are two angles, oops, that equal what? What do you think it is? 180. Complementary, supplementary. Alphabetically, C comes first. That's the lower number. First letter in the alphabet, first in the alphabet, lower number. Supplementary is further along in the alphabet, equals 180. Okay? So they're telling you that supplementary angles are linear pairs. Okay? Well, yeah, they make a line, hello, 180 degrees. So a linear pair is the same as supplementary angles. And they all equal 180 degrees. They make a straight line, okay? So look, if I come back up to my picture, what if I looked at, I don't know if you can see my light blue. What if I looked at angle 7 and angle 8? Do you see when I put the arcs, remember these are called arcs, A-R-C, part of a circle. Look when I put my arc on. When I add these two together, I'm making a straight line, right? So these are supplementary angles. I'm going to draw a line up here. When they're side by side, they make a straight line. There are tons of supplementary angles. Look at these two. Wouldn't angles 6 and 8 be supplementary? They make a straight line. How about those two? Angles 5 and 6 make a straight line. Let's go up here. Angles 3 and 4 make a straight line. Angles 1 and 2 make a straight line. They're supplementary. They equal 180. Okay. More vocab. Combine this with the facts of alternate interior angles to learn about same side interior angles. All right, I got another one. So think of how we figured it out before. Same side interior angles are angles on the same side of the transversal, right? That crosses the line, and they're on the inside. Okay, I'm just going to leave it at that. Okay, so let's draw a picture of same side interior. I'm running low on space. Okay, I'll do my picture again. This might be my last picture. Parallel lines, transversal, same side interior, gosh darn it, I can't talk. Same side interior. Can I write with my pink? Oh yeah. Same side interior. Okay, so I'm not even going to put letters or anything on this. Okay, numbers. Same side interior. Okay, so interior inside the transversal, right? So it has to be in here on the same side. So inside would be in here, and these would be on the same side. Aha, clever. Now look, this corresponding angle would be here, right? This angle matches this one. So if I put these together, they would be 180 degrees. So these equal 180 degrees. They're not congruent. They're supplementary. And if you notice, this one's acute and that one's obtuse. And when I put them together, they equal 180 degrees. Same side interior. These two go together. Other same side interior would be the blue ones. Same side interior. Now these two would have this. These would have the same measure, right? Because these are alternate interior. Those would be congruent. These two would be congruent, alternate interior. And then to freak you out some more, these two are linear. These are linear. They make a straight line. It's a lot going on. I know. That's why we took notes. Okay. Let's finish this out. Here's some more relationships. So they're going through and just telling you some things that they see. Angle 2 and angle 5 are vertical. Let's go look. Are they opposite of each other? Yep. Angle 2 is congruent to angle 5. They have the same measure. Angles 1 and 2 are corresponding angles. Angles 1 and 2. Corresponding means the same location at the intersection. And if you look, they're both upper right. Angle 1 is congruent to angle 2. That means congruent to. identical. Okay. Let's keep going. Angle 1 and angle 5 are alternate interior angles. 1 and 5 are alternating interior inside the parallel lines. And those are also congruent, right? Angle 1 and angle 5, those are both acute angles. They both have the same measure. Angle 5 and angle 6 are a linear pair. Look, 5 and 6. If I put them together, they make a straight line. So the measure of angle 5 plus the measure of angle 6 should be 180 degrees. Notice there's no congruent symbol here. Those are not the same measure. So they are not congruent. Okay, last one. Now we get to do some math. Name other pairs of corresponding angles, alternate interior angles, vertical angles, and a linear pair. Okay, let's do the first one. Let's do the corresponding. Corresponding angles are the same location at the intersection. So go up here to the picture. I'm going to erase my marks. Oh, sorry, squeaky pencil. Which ones are at the same location? They used 1 and 2, so we can't use 1 and 2. How about 7? 7 is upper left. So which one is corresponding? Which one goes with it? Number 4. Corresponding angles would be angle 7. Whoops. Well, here I can I do the angle 7 is congruent to angle 4. Be careful. Don't make that look like a less than symbol. I kind of did. Remember, this part sits flat, so that's what it's supposed to look like part of a triangle. Okay. Are there other corresponding angles? Sure. 1 and 2 are corresponding. 7 and 4 are corresponding. 2 and 3 are corresponding. If they had given me more numbers up here, there would be more. Sorry, I'm getting off the page. Let's do alternate interiors. So alternate interior angles. Okay, you start looking. Inside and opposite. So which did they use? They used 1 and 5. So don't pick 1 and 5. All right, well that leaves another pair. 7 and 6 are alternating opposite sides of the transversal and they're inside the parallel lines. So angle 7, and these are congruent, right, is congruent to angle 6. They're also alternate interior. Now let's do vertical. I like these. These are my favorite. Vertical angles are opposite angles. So which ones are on the opposite sides? Think of the V. They used 2 and 5. So they said these two are opposite. Well, look across from them. 4 and 6 are vertical. That's really it, right? Because they didn't give me other numbers. Okay, so 4 and 6 it is. And notice they're both obtuse. They're the same measure. Angle 4 is congruent to angle 6. We're almost done. Hang in there. And the last one says give a linear pair. Okay, I need 2 angles. They won't be congruent, but they're going to equal 180. They used 5 and 6. They used these two, so don't use those two. We have a lot to choose from. We could go 7 and 1, right? These would be a linear pair. 4 and 2 would make a linear pair. 2 and 6 would make a linear pair. 4 and 5 would make a linear pair. I'm going to go 7 and 1. You can pick whatever you want. So I'm going to say the measure of angle 7 plus the measure of angle 1 equals 180 degrees. I kind of wrote it just like they did. All right, my friends, it's a lot of vocab. If you slow down and take your time, you really, 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 really should rewind this and write these notes and draw them, okay? All right, my friends, your homework, or your practice work, you can do it today, you can do it tonight, whatever. Your practice work is going to be practice and problem solving, page 219 and 220. Okay, hang in there. This is a lot of words, but it's not overly difficult. You just have to remember who is, what is what. Maybe make a list of these. Okay. All right. I'll see you guys. Bye.